In section 11.8, we're going to talk about spheres. So let's start this section by first defining what a sphere is and certain special segments that are inside of the spheres. So first, a sphere is the set of all points in space that are equidistant from a given point called the center of the sphere. So this definition is a lot like the definition of a circle, which says it is a set of all points in a plane that are equidistant to a given point called the center. But this one is the set of all points in space. So we're talking three-dimensional. A circle is two-dimensional, so flat. A sphere is three-dimensional. Next, we are going to go over three more vocab words. So a radius is a segment from the center to a point on the sphere. So looking at the diagram, it would be from here out, so the red segment right there. A chord is a segment whose endpoints are on the sphere. So again, looking here, each of the endpoints are on the sphere, connected to each other. So then it would be a chord, much like the definition of a chord of a circle. And a diameter is a chord that contains the center of the sphere. So again, all three of these vocab words are very similar to the radius, chord, and diameters of a circle. We're just talking about now in a sphere. So again, two-dimensional versus three-dimensional. Our first theorem has to do with the surface area of a sphere. So here's theorem 11.11. The surface area S of a sphere is S equals 4 pi times r squared. So as long as you have the radius, you just take the radius squared and then multiply by 4 pi. Big S refers to the surface area. So you're literally saying if I were to take this sphere apart and lay it flat, what would the area of that be? So surface area is just the area if you were to take a three-dimensional figure and lie it flat. So again, make sure you write down this formula in your notes for the surface area. So let's look at example number 1. Find the surface area of the sphere. Remember, to find the surface area, you need to know the radius, which we are given in this problem. So let's start off with our formula. The surface area is 4 times pi times r squared. So we're just going to put the 12 in for the r. So we have S equals 4 pi times 12 squared. Follow the order of operations. So we're going to square the 12 first. So 12 squared is 144. They didn't tell us to leave it in terms of pi or to round it, so let's just do both of them. So 144 times 4 is 576. So our exact answer is 576 pi. Our approximate answer would be just to take the 576 times pi and get approximately 1,809.56. And since it was feet, we're going to say cubic feet for our final answer label. And now here's example number 2. They want us to find the diameter. They give us that the surface area is 40.96 pi. So we're going to work backwards. Let's start with our formula. S equals 4 pi times r squared. We'll put the 40.96 pi in for S. And we're going to solve for r, and then once we know what r is, we'll just double it to find the diameter. So we're going to work to get r by itself. So the first thing I'm going to do is divide by 4 pi. The pi's are going to cancel, and then 40.96 divided by 4 is 10.24, and that's equal to r squared. So now I'm just going to take the square root. So the square root of 10.24 is 3.2. So the radius is 3.2. So again, we were asked to find the diameter. So now that we know what the radius is, we'll just double it for the diameter. So the diameter would be 6.4. And since the surface area was squared inches, the diameter would be just inches. Next, we're going to see some more terminology. Within spheres, we have these things called great circles. So let's talk about what those are. If a plane intersects a sphere, so if we're looking at this diagram, we have the sphere and then a plane, so a two-dimensional flat surface is intersecting through the sphere. The intersection is either one point or a circle. So if you look at this, if I just put a flat surface sitting on the outside of the sphere right here, it would just be sitting on one point on the sphere. It would still be intersecting it, but just at one point. Or if we're cutting through the sphere like it is here in this picture, notice that the intersection, the cross section, is a circle. If the plane contains the center of the sphere, so again, if you notice here that we have the circle and the center is on that intersection, then the intersection is a great circle of the sphere with the same circumference of the sphere. So what this is saying is whenever you take a flat surface and cut through the sphere like we did here, if that circle, that cross section, contains the center of the sphere, then that is considered a great circle of the sphere. And that great circle would have the same circumference as the sphere itself. Every great circle separates the sphere into two congruent hemispheres. And this word should be familiar to you because we have like the northern hemisphere and the southern hemisphere. And we have the eastern hemisphere and the western hemisphere. So again, a great circle cuts a sphere into two congruent hemispheres. Example number 3. A globe of Earth is a model of a sphere. The circumference of the globe is 18 pi inches. Find the surface area of the globe. So in order to find the surface area, we need to know the radius, since the surface area is 4 pi times r squared. Since we know that the circumference of the globe is 18 pi, we can work backwards and find the radius to then plug into our surface area formula. So again, let's start with the circumference. We know circumference is 2 pi r. So we're going to put the 18 pi in for the circumference to again work backwards to find the radius. So if it is 18 pi equals 2 pi r, I'm going to divide by 2 pi. The pi's will cancel, and 18 divided by 2 is 9. So the radius of the globe is 9. So now I can take this and plug it into my surface area formula to now find the surface area of that globe. So we have surface area is equal to 4 pi times 9 squared. So again, we would take 9 squared, which is 81, and then 81 times 4, which gives me 324. So my exact answer is 324 pi, but they're just asking for the surface area of the globe, which is like a real life situation, so it wouldn't make sense to leave our answer in terms of pi. So taking 324 times pi in my calculator, I get that the surface area is about 1017.88, and it would be inches squared since it's a surface area. Next, we're going to talk about the volume of a sphere. So here's our next theorem, 11.12. The volume of a sphere is V equals 4/3 pi times r cubed, where r is the radius. So again, as long as you have the radius, you're going to take 4/3 times pi times r cubed. Just like always, I'd figure out what the pi times r cubed first is, and then I would multiply by the 4/3, like we did before when we were finding the volume of pyramids and cones. Again, make sure you have this formula written down in your notes. Volume is equal to 4/3 pi times r cubed. So I'm going to type in 7.5 cubed in my calculator and then take that times 4/3, which gives me 562.5 pi. So there's my exact answer, because again, it's not telling me to round to a certain decimal place or leave it in terms of pi. So I'm just going to do both. So again, I have 562.5 pi, and then a decimal approximation. I'm just going to take the 562.5 times pi in my calculator to get about 1,767.15. We were told the diameter was in inches, so this would be inches cubed for my final answer. And now on to example number 5. Find the volume of the composite solid. So notice that this is a cylinder first with a hemisphere over here and a hemisphere over here, so half of a sphere. If I put this hemisphere combined with this hemisphere, I'd get a full sphere. So I'm going to do the cylinder plus a sphere to find the volume of the composite solid. So let's first find the volume of the cylinder. To find the volume of a cylinder, I got to take the area of the base times the height. The area of the base would be this circle with a radius of 2. So that would be pi times 2 squared times the height, which is 7. So let's just leave that in terms of pi to keep it as exact as we can. So 2 squared is 4, times 7 is 28. So the volume of the cylinder is 28 pi. And again, I'm going to find the volume of this hemisphere and this hemisphere by just saying I'm going to find the volume of the sphere together. So the volume of the sphere, it is equal to 4/3 pi times r cubed. Well, we know that the radius is 2, so it's going to be 4/3 times pi times 2 cubed. So again, I'm just going to leave it in terms of pi to begin with so I can keep my answer as exact as I can as we go along. So I'm going to take 2 cubed times 4/3 in my calculator, which gives me 32/3 pi. So now I'm just going to take these two answers and add them together. So the volume altogether would be 28 pi plus 32/3 pi. And I'm just going to do a decimal approximation in my calculator to get about 121.47, and it would be centimeters cubed. So there is my final answer. That's it for this section. Make sure you jot down anything you did understand that we can cover before we move on in class, and we'll see you then.